Okay, some more HSC questions here involving the sum of series. We're asked to evaluate the series 2 plus 5 plus 8 plus 11 plus a whole bunch of numbers in between, and the last term there is 1094. So we know it is an AP. Just looking at it, I'm going up by 3 each time, each between terms, so my difference is 3. My first term is 2. So, as we usually do, we're going to start off with an expression, an equation here for t, the nth term of the series is 2a is a plus n minus 1 times our difference. So that's going to be, pardon me, I should have substituted that in there because we know our difference is 3. We're going to end up with 3n minus 3 plus 2, which is 3n minus 1. Okay. Triple whatever term it is and then subtract 1. That's our equation for Tn here. So if we're going to add all these up, it would be very foolish to go and try to add them up by saying 2 plus 5 plus 8 plus 11 plus so on and so forth, because there's a whole bunch of numbers in here. We're going up by 3, we end up at 1,000. That's somewhere in the vicinity of at least 300 terms. So we don't want to be going and adding them up individually. But what we can do is we can go find out what number this term here is in the series. So if we go and if we let t to the end, or the nth term be 1094, we can go find out what number term that is. So that will mean that 3n minus 1 equals 1094, or 3n equals 1095, and that means n is going to be 365. Okay, well now that's actually very useful for us, because what we can do now is go and use our sum of an AP formula to go find out what our sum is. Well, we can use Sn, the sum of, well in this case n is 65 terms, 365 terms. Go and say 365 on 2 outside of the first term plus the last term. When you've got the last term, this is a much easier alternative than going and work using 2a plus n minus 1d, and what that comes out to be is 2,000,20. Okay, now of course we're adding up essentially 1100 and then 3 less than 1100 and 3 less than that, so our sum is going to be quite large there. So that answer does seem quite logical to us. Alright, this time we've got a limiting sum question. Our sum as we approach infinity is a over 1 minus r. Of course, r is between 1 and -1, but not equal to 0. And here we have a being equal to 1. Now, we need to go find out what our common ratio is. Well, something I notice here is we go from a positive 1 to a negative, positive, negative, positive, and so on. So that means my ratio will be negative. Okay, my ratio will be a negative number. And then what we notice is that we could use any terms. We could go T2, so a negative 1/4 divided by 1, which will just give me negative 1/4. We could do the same thing here, 1 on 16 divided by negative 1 on 4. That'll also give me negative 1/4. My ratio is negative 1 on 4. First two are probably the easiest to use. And well, then we've only got two variables in here, a and r, so we can just go find the limiting sum, or the sum as n approaches infinity, which is 1 over 1 minus 1/4, which is 1 over 5 on 4, which is 4 on 5. And what you notice is these terms go back and forth, so because it goes positive, negative, we end up with 1 minus 1/4 is 3/4. Then we add 1 on 16, it goes up a little bit, and then down a little bit, and up and up and down and up and down, and we end up with 4/5 or 0.8 as our limiting sum there. Okay, here we're asked to find the sum of the first 21 terms of this series here. Now this one is an arithmetic series. It means we have a common difference. So straight away, the things I'm doing each time we do these type of questions, write down our first term. Write down everything we know. A is 3. Our common difference is 4. We know n is 21. So we could do this a few different ways. I think probably the easiest way is to actually use our sum of 21 terms is n over 2 outside of 2a plus n minus 1d. I'm not a big fan of this version of the formula, but in this case I think it's the most helpful because you're essentially going to do the same thing if you went and found the 21st term by using a plus n minus 1d and then put it back in here anyway. So I think this is a good time to use it. So it's 2 times 3 plus n minus 1, so we know n this time, n being 21 minus 1 multiplied by d, which is 4. Okay, so we end up with 21 on 2. We end up with 6 plus 20 times 4 is 80. So if we put that into our calculator, we'll end up with 903 as our sum for the first 21 terms there. Main thing with these type of questions is get your information down to start with, work out whether it's an AP or whether it is a GP or an arithmetic series or a geometric series, and then go and think about which formula you're going to use. Look at that reference sheet, make sure you're using the appropriate formula, don't get them mixed up between an AP and a GP, and these type of questions really should be pretty straightforward.